So I'm building an electric motorcycle in my garage, and this is the story of how I'm building the battery pack. So I started this journey on the electric motorcycle conversion over a couple of years ago, and I've been posting Instagram Reels and YouTube Shorts, and I thought it was time to give my first YouTube video a go. I've shared bits and pieces of the project on Reels, but I found it really difficult to get into any meaningful detail within 90 seconds. So here we are. The journey originally started because my brother and I were looking for our next engineering project to try our hands at. And at the time, I was working in a shop that did custom electric conversions for classic cars. I wanted to do a project, and a car conversion was out of budget, but a motorcycle was perfect. We started the journey by 3D scanning the frames of the motorcycles to get an idea of the lay of the land in the space we were working in. The shape of the motorcycle frame is quite awkward, so it makes sense to design a battery pack to fit within the contour of the frame. And with modern CAD, I can actually design the battery and the modules to fit in pretty effectively within the contour of the frame that we're working in. Getting to the modules, it was quite an interesting design puzzle to attempt to solve. And my initial design is completely different to what I've ended up with now. To simplify the design process, I wrote down the main requirements of what needed to be satisfied for the design to work. Firstly, I needed the battery pack to be split into units that were of a modular design. Secondly, I needed each unit to handle the electrical power output of the system. And thirdly, I needed the layout to allow for good busbar routing between the modules. I needed a way to slice this battery pack into 4. This number made sense to me because the battery would only really fit 4 cells wide. I chose 18650s because they're just such a readily available and common cell. I needed 28 cell banks in series, which is 7 cell banks per modules. All of this worked out nicely to a 4 module battery pack. I designed an initial concept for the cell module. Now, this here is each cell group, and this is the electrical conductor that connects the cell groups together. The idea is that I have 4 of these connected together, which make up the battery pack. What I discovered is that this first way of laying out the connection wasn't actually very favourable to maximising the current carrying capacity. Let's break down why. What happened here is that I stacked each cell group in a horizontal fashion on top of each other, and this left the conductor with very little cross-sectional area. So, you see, you want to maximise the amount of area that the electricity has access to flow through. So, kind of analogous to a hose, like if you have a massive hose with a huge diameter, then there's going to be very little resistance to the flow of water. But if we shrink that hose down, all of a sudden there's going to be a lot more resistance. And the same is true when it comes to electricity. You can see here that the first concept has the group of cells sitting on top of each other vertically. But what I did is change the cell groups to sit horizontally next to each other. As a result, this area here, the conductive area that carries the electrical current, has doubled. All of this is useless without actually being able to connect the bus bars together. If the modules require a super extravagant bus bar that is impossible to fit, then the design won't work. Now, this became quite a problem in my first design because the bus bars just were not in a good position to connect nicely, and it was a concept killer. Now, changing those cells to a vertically stacked design actually had a pretty significant secondary advantage. Stacking the cells like that allowed the modules to be connected with these bus bars, which ran diagonally across the battery pack. Not only did this arrangement connect each cell group in a more convenient manner, it also used copies of the same part in each instance, which ties perfectly into the modular design that I was aiming for. At the time of design, I tried to squeeze in as many cells as possible, and this was just going to be shy of 1000 cells, which works out to roughly 10 kilowatt hours of energy. And as I said at the start of the video, with modern CAD, it just makes it so easy to design into every millimeter of available space, which is how I reached this figure. And the issue with this is it means that parts need to be made with that little bit extra precision. And this means more expensive parts and assemblies that are harder to build. Being slightly less greedy for space would have literally given me more space to build and made the build process a lot quicker. That being said, while I would go back and make the changes to design now, I had to choose a point that was good enough to start building, because otherwise I would be stuck in a continuous design loop, refining and refining without actually receiving any testing input, which is pretty dangerous, because what that means is I could just be refining in the wrong direction. So right now, I'm pushing towards building the first prototype to get on the road so I can validate the design. So I'm thinking in the next video of diving a little bit more into the battery casing design. I'm also happy to be guided by the feedback of the viewers, so feel free to comment down below what you want to see and any more questions you have about the project. And if you're interested in the project, like and subscribe to stay tuned for more content.